Okay, welcome. Welcome to this next session. My name is Dwight Goins, and we are going to talk all about the DP-200 exam, which is all about implementing Azure data solutions with all of the Azure data capabilities that live inside of the Azure ecosphere. So again, my name is Dwight Goins. I am a Microsoft certified trainer. I'm also a Microsoft regional director. You can contact me afterwards by taking a quick capture of that QR code up there that takes you straight to my LinkedIn profile. And go ahead and befriend me if you want, or just send me some kind, encouraging words. So today's agenda, we're going to talk about the certificate overview. And then we're going to talk a little bit about the exam objectives and go pretty deep into the various different objectives for DP-200. And then at the end of that, we'll talk a little bit about some strategies to think about and some tips and topics in order to figure out how to actually go about preparing and passing the exam, okay? So the key takeaway here that I'd like you guys to focus on is three main things. First thing is, what are the exam objectives and things that you need to focus and study on for the DP-200 exam? Number two, I want you to focus a little bit on the exam questions and the format of how the questions themselves are formulated so that you won't be hit for a surprise when you go in and take this exam. And of course, some notes, some study notes, some links, some references to how and indeed where to go for preparing for this particular exam. So first off, let's get started with the Microsoft certification overview. But before we go all into the DP-200 stuff, let's talk about why we are at this road, this crossroad in the certification world. By a show of hands, how many people have some of the older certifications? How many people here in this room are either MCSE or MCSD or and so on and so forth? Okay, quite a few of you. Good. Okay, well, Microsoft has been building the certification process for over 20 years, right? And we've had MCSD, Microsoft Certified Solution Developer. We had MCSE, Microsoft Certified Solution Engineer, right? And then we had MCDBA, which was a Microsoft Certified Database Administrator. And we would think that this exam would be specially geared toward the database administrator. And that's somewhat true. But what we've noticed is that being in MCSD or MCSE or MCDBA, the job roles and responsibilities have been convoluted. When you think about a database administrator today, a DBA is no longer just focused specifically on SQL and everything that deals with SQL. They're focused on all types of repositories. They're focused on NoSQL repositories. They're focused on MongoDB. They're focused on columnar-based repositories such as Cassandra. They're focused on graph repositories. They're focused on just regular SQL, right? So there's a wide range of different type of repositories, and it's no longer just pure SQL. So understanding that the roles have somewhat been convoluted as to the different technologies and frameworks that a particular person or engineer is focused on, the Microsoft certification also had to change gears. And that gear shift was based off of roles and responsibilities. So what Microsoft has done is created a new path for roles and responsibilities. And these roles, you can see here on the slide, are if you're interested in apps and infrastructure, you can go down the apps and infrastructure path. If you're interested in data and AI, you can go down that path. If you're interested in the modern workspace or the business application, you have those paths in which you can go down, all right? So let's talk about the data and AI path, because this particular course explicitly references that data and AI path. The data and AI path is for people who are interested in data and artificial intelligence. So that typically means people like data scientists, that typically also means database administrators, that also means AI engineers. So let's talk about those roles for a quick second. So a data scientist is really focused on the data from the standpoint of how can I build machine learning models based off of data that is around me. Sometimes they don't care about the structured data, they care about unstructured, unprocessed, raw data. That would be a data scientist. And then you have the database admin. They are all concerned about performance, the design, the flow of how this data is going to run. And now that our databases and our repositories are no longer necessarily all on-premise, some of them being in Azure, we're also focused about all of the mechanisms that deal with hybrid scenarios and scenarios where we have to make sure all the data is running up in the cloud. And then you have the AI engineer. That particular role and responsibility is kind of focused on how do we deploy the data models or the machine learning models that the data scientists have built? How do we work within the confines of what the database administrator has put in front of me? And how do I be the consumer of these machine learning models and database repositories that are out there for me? Right? So you have those three different roles that are focused on three different things, but they all deal with data. Hence, what we have here are exams that deal with those roles. So those exams that specifically deal with what this topic is about today is the DP-200. And it allows you to focus on implementing data in such a way that you can take advantage of all of the various different Azure data capabilities, from Cosmos DB to SQL to data warehouses, even a little bit about Databricks and Data Factory and how we interact with all of that together. So with that being said, one quick note about certifications. For those that have taken certifications in the past, I'm sure you're well aware of the multiple choice scenario where you basically are presented with a series of questions and a series of use case scenarios, and they give you A through E to answer the question. And we all know that, well, if you memorize the questions enough, if you memorize the answers, you could probably do pretty good by guessing, right? Take the all A approach, as some people used to say, right? The letter of the day. Well, now they've introduced, or Microsoft has introduced, performance-based testing. Performance-based testing is this idea where you have a web browser that runs a VM, or is launched into a VM. So you have the screen where you're in this environment, this VM, virtual machine environment. And they give you another piece of the page that says, do these 12 tasks. We don't care how you do them, just get them done. So you can write scripts, you can use PowerShell, you can open up Visual Studio, you can open up Azure Portal, just get the 12 tasks done. If you get the 12 tasks done within the allotted time, you pass. How do you think about that for performance-based tests? Exam overview. Now there's a lot, so bear with me. We're gonna cover a lot at a fast pace, and we're gonna try and take breaks in between. So if you have any questions, just wait toward the end, and then I'll make sure that I can cover as much as I can. All right, so for the DP-200, we have three major buckets. Okay, the first bucket you can see here is implementing on data storage solutions. It covers the majority of the exam, 40 to 30%. The next bucket we have is manage and develop data processing, which is the next bucket, and then monitor and optimize data solutions. Now, I'll be honest with you, I've taken this exam during the beta days, and the beta days had way more buckets than these three, so they've conglomerated it down to these three buckets, so that's good. But what that also means is that they're focused on something, all right? And one of the things they're focused on is how do you implement this data, right? What are the steps and the paths and mechanisms? And how do you choose which ones to actually implement? And then they're worried about, okay, once you've figured that out, how do you manage that data? How do you keep track of what's going on? How do you monitor it? And how do you choose the best optimization factors of it, right? So those are the key things that they're looking for. So let's first get started with implementing data storage solutions. So within this bucket, there are three sub-buckets. There are three small things that we should focus. And that is non-relational databases, relational databases, and then security. Yes, security is big inside some of these tests. So the first one is non-relational database storage solutions. So here's a scenario. A typical data engineer, and this is how Microsoft wants to really view this. As a typical data engineer, you may be tasked with having to support, implement, design, and build a solution that, let's take, for example, a e-commerce customer website type of application. External facing, people can hit this website, and whatever the case is some type of check-in, check-out cart mechanism. And as the requests are coming in, the data is being stored in some type of repository. Doesn't have to be relational, right? Data is coming in into some type of repository. And the design that we have on the screen here, we say Cosmos DB. Why Cosmos? Simply because Cosmos supports a multi-model type of repository. It supports a relational type of structure. It supports columnar-based. It supports graph. It supports many different type of repository types. So you don't know exactly what it is just yet, but let's just say you're presented with this scenario. And as the data comes into Cosmos, events are being generated. Now here's a key point here. Events could actually go into a non-Microsoft product. Yes, believe it or not, Microsoft does support other products. And one of those products might be Kafka. Maybe that's the event system. Or then again, maybe it's an all Microsoft product. Maybe it is event hubs. But whatever the case, you might have to support this eventing mechanism because that's what you're presented with as a data engineer. So understanding you may be presented with a scenario that has a design that kind of looks like this, you may be presented with multiple questions that deal with when should you choose one repository versus the other. Well, to understand this, you got to know what the different repositories are and what's supported inside of Azure. Obviously, you know Azure SQL is supported, so you know the typical SQL scenarios, all right? But we also have Azure Data Lake, and you'll see information about Azure Data Lake. By show of hands here, how many people have heard or have used Azure Data Lake? Even better. So if you've used Azure Data Lake Gen 1, then Generation 2 or Version 2 of Azure Data Lake should be a quick, easy hop for you. And the exam doesn't really ask questions about like the technical differences of Gen 1 versus Gen 2, other than when you should use one over the other. And pretty much the answer is always use Gen 2, right? You would see a question that really focuses on something like, the only time you would choose Gen 1 is you're mandated by some requirement that says you can't upgrade, right? So if you see a question that says you can't do any upgrade, then you know whenever there's a question that deals with Data Lake Gen 1 versus Gen 2, choose Gen 1. But for the most part, always choose Gen 2, okay? So for those that are not familiar with Data Lake is really just a repository that supports the raw, unprocessed, unfiltered set of data. Supports text, supports binary. Basically, it's just a big buttload of data. And you could just send any type of data that you want into it. And it's typically perfect for machine learning and data science engineers because that's what they want. They want a big bucket where they can get to all the type of data so they can crunch numbers and crunch data from it in such a way where the machine can learn from that data. They don't want to estimate or assume anything about the data. So the best way to do that is to give them raw, unfiltered, untouched, unprocessed data. And that's what Data Lake is for. So if you see any questions that ask something along the lines of, you're trying to use machine learning, you're trying to use unprocessed data, right? Typically Data Lake is going to be somewhere involved in that solution. The next thing we have is the blob storage. So the blob storage is pretty obvious. That's for binary large objects. And for blobs, we typically work with media files. We typically work with audio and video. Just raw, unstructured data is what you're going to use blob storage for. And then we have Cosmos DB. Cosmos DB supports many different types of repositories. It supports the table row design, relational, right, which is different from Azure SQL. Just make sure you understand that. But it also supports columnar-based designs, which is Cassandra. It also supports graph databases as well, which are pretty much linked nodes, okay? And it supports these type of mechanisms. So all of that inside of Cosmos DB. So if you have any questions that deal with things like, you need to build a highly relational child-parent type of design or some type of thing that deals more so with links and relations than your typical order parts processing, you most likely would choose Cosmos. Now, as we start to drill down into these different non-relational structures, we need to talk a little bit about data distribution and partitions, because this is also pretty heavy on the exam. Data distribution and partitions is all about this concept that when you choose, let's say, a Cosmos DB design, everything in Cosmos is kind of considered what we refer to as a container. A container could be considered a table, it's any type of generic collection, right? It's this idea where it's just data it's contained in a particular location. And when we talk about data distribution, it's how do we divide up those locations? Now we have two different ways or we have two different ways that that data is divided up. One way is a physical partition, and one way is a logical partition. The logical partition is divided up by a key, which you provide. So that goes into this concept of logical partitions versus physical partitions. The logical partitions are based off of a key, and why that's important is because if you choose the wrong type of key when you're building your logical partition, it could pretty much throw off your performance, it could throw off your design, it could cause timeouts. So understanding which key to use in your data is very of the utmost importance. And so they will ask questions about that, okay? So typically, how do you figure out what key? Well, there's a couple of different patterns that you can use, but the easiest pattern is think about your where clause. If you have some data that you need to query into, you're going to query and filter based off of some where clause, right? Well, if you think about what the values are or what the fields are that you use in your where clause, those are typically good candidates for your partition key, typically. Not all the time, but most of the time. Another way to do it actually requires some real work, and it's more of a mathematical process to do it, and that is, take a look at your data, take a look at your queries over time, and figure out what type of fields are being queried on the most. And then once you figure that out, that's how you figure out your key. But that's a kind of an after effect thing to do it that way. All right, next thing we have is consistency models. So this might be a nice loop. When we talk about the cloud, we must make mention of the fact that we need high availability, because when you design for the cloud, things can go wrong, right? You have network latency issues, networks can go offline, right? And you have the fact that the cloud, for the most part, may not be as resilient if you don't design it right. So you need to think about what happens when things go offline. So Microsoft has made it easy for us to think about this because it allows us to replicate data across regions, across locations, across physical boundaries. So that makes life easy. But what that also does is it introduces some other problems. It introduces data inconsistency. Because once we replicate data from part A to part B, or physical location A to physical location B, there's a sync that needs to happen. And what happens if that sync doesn't happen? And what happens if that sync takes a little bit too long to happen? Your data is not going to be consistent between environments, right? So we have different consistency models on what you need to design and build for, and the question asks you a few questions, the test asks you a few questions on this. So one of the things that we need to understand is the different consistency models. We have, what's up here? We have the strong consistency model, the bounded staleness, the session, the consistent prefix, and eventual. So what those models basically mean is this. The strong model is similar to your typical relational database asset properties, right? Once you are uploading and updating data, it waits for the full commit to happen in order for the reads to be available to read the latest data. All right? So it's your typical SQL relational type of commit pattern that we're talking about. So that's strong. The problem with strong is you're not going to get a lot of throughput with strong. And another problem with strong is that out of all the options, it's the most expensive. So when they ask you questions about that, keep that in mind. The next model we have is bounded staleness, and that's the easy one to understand. That's this idea of saying at most this amount or within this time frame. That's the easy way to thinking about the staleness. So you're saying, okay, I want to be updated to the top 5 records. So 5 records come in, that's okay. Anything more than 5 records, they come in and get updated, then I'm going to say that's inconsistent. I want the data to be updated and refreshed. Or I could say, when the records come in, it has to be within 5 minutes, so all the records within 5 minutes, so I have up to a 5-minute mark where I am potentially inconsistent. After 5 minutes, everything needs to refresh. I need to get consistent again. The data needs to all be in sync, right? Because that's my rules. That's my SLA. Is that clear? Everybody with me? All right, so that's the bounded staleness. And then we have session. Session is pretty easy. You create a session for the user for this application. So whatever session that they are in running, if they make an update, they can immediately see their own changes. So read your own rights. That's the idea of session. And then we have consistent prefix. It's a little bit more interesting model. So this scenario is, let's say that we have user A and user B uploading to the same record or document. And user A uploads field first name, user B uploads field last name, and then user B moves on to another record, okay? And then you have another user that's reading these updates. So in the case of consistent prefix, what winds up happening is the user that's reading the updates from user A and user B, they won't see the update of record number 2 until all the updates of record number A, the first record from user A and user B, get updated. So you can be guaranteed read order and guaranteed write order, all right? But you may not be in a complete consistent state immediately, right? So that's the idea of the prefix. And then last one we have eventual. So eventual, out of all the models, costs the cheapest. It's the least amount of expense. And it's the fastest performing out of all the options. But guess what? Your data is not consistent. It eventually get there. So you could design for that. All right. So next part we have is provision a non-relational data store. Obviously, we can use Azure Portal to provision. There are no questions on how to use the portal to provision. Sorry, there's no like picture that says click here to do this. But there will be questions on how to use PowerShell or Azure CLI to provision this. And the questions are not type it in from scratch. They're more along the lines of understanding what the different parameters mean, and they'll try and throw these little tricks as to remove some of the parameters. These are the parameters that are needed. You need parameters such as the name, so pay attention to things like the name, the resource group, the location, the standard SKU, and the kind of storage that you're going to send it to. Concepts and APIs. So when they talk about this bucket, they just want you to understand knowing the differences of the various different APIs that are available inside of Azure. So they want you to understand, number one, what Cosmos DB is and the fact that it has multiple repositories, right? Again, it has the graph repository, has the table repository, has the columnar-based repository, and it also has queues. Right? So it has quite a few different type of repositories that you can use. And the most important piece I want you to take away here is that there are different APIs for different types of repositories in Cosmos DB. So Azure supports accessing Azure SQL, again, separate thing, but there's a SQL API for that. But going back to Cosmos, Azure supports the Gremlin API, which allows you to access the graph part of Cosmos. Azure supports the MongoDB through Leaf to access DocDB part of Cosmos, or of course you can actually access a MongoDB instance if you didn't want to go through Cosmos. Azure also supports the table API to access the table repository in Cosmos. And last but not least, the Cassandra API to access the columnar-based repository that's supported. So if you know about those APIs, the exam will also kind of talk about development, so you may need to have some code snippets there from C# to understand like how to use these APIs in code. But most of the exam questions are really focused on understanding the differences between these different APIs and knowing when to use what. Security. So when talking about security, what you need to understand here is you need to do all of the best practices for security. The best practices are, make sure when you set up your Cosmos DB or non-relational data structure that you put it behind a firewall, so you make sure firewall is enabled, and you open up whatever individual ports that you need for that repository and close everything else. So that's key, because they ask questions dealing with that. They also want you to enable authentication. So because this is in Azure, you probably want to use Azure AD. If this were SQL, of course, you have a mix. You can use SQL authentication as well. But the going rule of thumb is try and keep everything in Azure AD. That's going to give you the best and most secure design, depending on what you're building. The next thing you want to do is enable encryption. Now, by default, when you create an Azure storage account, encryption is going to pretty much be turned on for you. So it's pretty pretty much nothing you have to do there, but just make sure it is enabled. So now this starts to get us a little bit into high availability. So with Cosmos DB, we have different type of tiers that we can run on. We have the lowest cost tier, also known as the standard tier, and we have the premium tier. Now, the lowest cost tier does give us a small form of high availability in the sense of, if you think about what's happening with your repository, there's a lot of pieces, right? Internally, in Azure, there's the actual physical disk where the data is stored, right? You have SSD drives and different things of that nature. And then you have the compute power. You have the CPU power that's computing and running your queries and running your processing of the data, right? So all that's kind of packaged together, right? So when we talk about the standard tier is going to give us availability from the standpoint of, yeah, we'll replicate your SSD drives and we'll make sure those drives are up, and we might give you multiple CPU instances, but it's all going to run in the same region, okay? When you need something a little bit more than that, that's when you bump up to the premium tier. And the premium tier allows you to replicate exactly what you have and your standard tier in your one region over to multiple regions, and even physically across the world if that's what you needed to do. But the only way to do that is with premium tier. So understanding that will go into quite a few questions that talk about high availability. But along with that comes this idea of multiple master replication. So multiple master replication is this idea that we're using a premium tier to replicate our design between one region to another region. And what you might see on the exam is how to turn this on. So key takeaway here is that you need to be in a premium tier to figure this out, right? It won't work in standard tier, only works in premium tier. And how you actually turn it on is what you see on the screen here. Pay attention to the last 3 lines. The last 3 lines say, okay, what region and location do you want this master replication to be replicated across? And the last line is enable it, turn it on. Multiple rights is what it's referred to as. So we talked all about non-relational databases. These are some sample questions that you might get thrown up or you might see. Anybody want to try and take a stab at one of these? So the first question says, this is a true or false question. You have a unique ID, a current date, and a location. So these are like fields, I guess. For each individual product sales stored in Azure Cosmos DB, you should create a partition key based off of the current date. Now, how many people say true? By a show of hands. How many people say false? Okay, a few of you. How many people are just totally clueless and say, I have no clue? Okay, no problem, no problem. So false is the answer. If we base it on current date, let's say, right? Current date might spawn across multiple regions that we query. It might pull back too much data. And what happens when you pull back too much data is, depending on your configuration with Cosmos DB, we have something called request units. And you basically are charged per request unit. A request unit is basically like a GET call, right? You just go out, do this GET request, and you're charged per GET request, if you look at it that way. And if you think about a query per current date, that GET request will pull back a whole bunch of data, and it may do a bunch of gets across multiple partitions, which would cause a lot, could potentially cause you a lot of money. So the best one would be to use like a unique identifier, such as unique ID, right? That only pulls the data for that specific region, for that specific logical partition, all right? All right, one more. Let's do, which consistency model trades best performance for data consistency? So which one gives us the best performance, but may not be in sync all the time? Eventual, exactly. Everybody understand that one? Is that pretty clear? No? Well, again, when we talked about consistency models, remember we said strong model? The strong model is the one that's like a relational database. That model basically says, okay, we're going to wait to make sure everything is in line before we allow people to read, right? So that means that it's going to do a little bit of a blocking, right? It's not going to give you the most throughput. So the performance is going to be a little bit lower than one that says just blast everything in, and if you're not up to date, so what? You can continue to read, you just might not be reading the latest and greatest, which is exactly what eventual is. So they're total ends of the spectrum. So strong is up here, eventual is down here, all right? All right, so take a break. Everybody ready to move on to the next piece? All right. This next piece is all about relational databases. So in the case of this exam, relational databases is pretty much up your alley if you're a DBA, right? It's working with SQL, but it's working with Azure SQL. It's not working with SQL on-prem, nor is it focused on SQL in a VM running in Azure. This is all about Azure SQL, all right? So it should be obviously noted without said, you should know your SQL commands, select, insert, update, and delete, create table, drop table. You should understand that, right? That should be gone without saying, but I just said it anyway. But it's also going to cover data warehouses. So know a little bit about SQL Data Warehouse. And believe it or not, Microsoft does support some open source SQL relational databases. Yes, Postgres and Maria, as well as MySQL. So Maria is nothing more than MySQL. It's just a fork of MySQL. But the questions that you may be presented with there more so deal with understanding which open source databases are supported by Azure, but not any specific details about those open source databases. Just understanding that they're open source and that they're relational, so everything that you understand about relational pretty much adheres or follows thought with these databases. So when we talk about Azure SQL, you have to know a little bit about the options when creating it. So some of those options are resource group, location, and one of the most important pieces is DTU. DTU stands for the Distributed Transaction Unit. And the DTU is all about this idea that if you think about an on-premise SQL server, think about on-premise for a second. On-premise SQL Server has a SQL Server exe that runs, right? And then it has the data. The data is stored on some physical disk. And then you have a log file that typically is stored on a completely separate disk. And then you have indexing, you have statistics, you have all these things that are running. You have memory that's important. So if you think about on-premise, it's all these things that you got to worry about with a physical server. Well, we're talking about SQL Server in the cloud now, and believe it or not, it's the exact same thing, but it's packaged together for us. So DTU is the packaging of the compute power, the memory, and the storage for the most part. So that's what DTU is all about. And what makes DTU interesting is that it's a fixed DTU. It's a fixed set of compute power, storage, and memory. Meaning that Microsoft gives you some predefined values. So performance is based off of that DTU value that you choose. Do you want 4 gigs of memory with X amount of storage with this particular CPU? Or do you want 16 gigs of memory? Or do you want 32 gigs of memory? Or do you want a terabyte of memory? So on and so forth. They're all fixed. We also have another form of this DTU. It's called vCore. vCore is this idea that we can configure compute or configure RAM or configure storage. So it's not fixed like DTU. And last but not least, we have something called elastic DTU. Okay, elastic DTU is this idea where, okay, I have a set of resources on a server and I just want to share those resources on that particular server. So to really get a clear view of DTU and vCore, here's a chart that kind of explains it. DTU is kind of linear. It's a preset set of compute power and RAM and storage, and they just give it, Microsoft just gives it to us as a package. We can't tell it, well, I don't really want 7 gigs of RAM, I really want 8 gigs of RAM. Well, if they only give you 7, guess what? You got to bump up to the next one to get the 8. And if that means going 32, that's what that means. Whereas vCore is more like virtual machines, kind of like. It's this idea that I can be very specific about what I want. I can configure the storage, the RAM, the memory, and so on and so forth. Hence, in the chart in the vCore, you kind of see the points all over the place. Clear? So let's talk about elastic storage. Oh, one more point about these two. So this is what we refer to as elastic pools, in case you're wondering. So elastic pools are all about this idea that I want to choose how strong my servers are and how many servers that I want to use based off of distributed transaction units and based off of vCores, okay? So we also have this thing called the eDTU, the elastic DTU. So this is the idea where I want to share resources on the server. Because we all hate the fact that when we have on-premise servers, if we have an on-premise database, the problem is that sometimes if you don't have a high throughput application that's constantly pinging your SQL, most of the time your SQL server is doing nothing. It's idle. So you're wasting money, right? You're just paying for resources that are not being utilized. So this is this idea we can take advantage of that and say for any piece or server in the cloud that's not being utilized, let's share the resources so when it's not spiking, we can use it with another app or another database. So if we want to follow this example, follow the blue line that's up here. So the blue line is DB1. So in this blue line, it's telling us that it's going to really start peaking at 12:05. That's when it starts. And then it really peaks at 12:10, and then it starts to go back down at 12:15, and at 12:20, it goes basically to nothing. So from 12:20 to it starts back up again at 12:55 at the end, it's doing absolutely nothing. So what we can then do is when we use this elastic pool, we could say, let's add another database onto this server so it could take advantage and when it peaks. So if you take a look at DB2, which is the orange line, it's going to peak at 12:20 and 12:25 and 12:30, and then by 12:40, it's doing nothing. So we could take advantage of the idleness of this. So this is good because now you're really getting full use out of your server and it's not just idly wasting time. So that should then prompt you into thinking, this is really only going to work when we have applications and processes that do peaks and valleys and trolls up and down. Not applications that have a real-time, constantly ping the server type of mechanism. And that's what this slide is really talking about. When is the best cases to use the elastic pool where you get these peaks and valleys, and when is it not? All right, so configuring geo-replication. So this is a topic that you see, I probably see maybe 1 or 2 questions on, not very big. But the question here, or the concept about this, is understanding that when you use high availability, we have the ability of replicating your data across regions. Now, what you probably want to read about and go into here is understanding things like local redundant storage versus geo-redundant storage versus read-access geo-redundant storage. I won't bore you with the details, but it's fairly easy to understand. Local redundant storage means you're pretty much staying in one location. Geo-redundant storage means that you're going to have redundancy across your storage and across multiple regions. And then you have this idea or this concept of a read-access form of it, which even goes a little bit further, which says not only are we going to replicate across regions, but we're also going to give one more replication only for read-only purposes. Okay? So understanding about the redundant storage options is good. They're not going to ask you to define what they all mean. They really just want you to understand the differences and you kind of know when to use it. Obviously, if you have a question that deals with high availability, or you have a question to deal with, you need to replicate your data across regions, that's when you would choose those different type of options. And again, with security, exact same thing when we talk about with Cosmos DB. Enable the firewall, enable authentication, use Azure AD if that's what you need to do, encrypt your data at rest, right? These are all important things that should be focused on when any security questions are being asked. Another point to take away here with high availability is the tiering model. So with Cosmos DB, remember we talked about a standard tier and a premium tier, right, and the multiple master rights type of thing? Well, with SQL databases, with relational database structures, we have the same type of thing. We have a standard tier, and then we have a premium tier. But the difference with relational databases is that when you have a premium tier, we have a cluster. Okay, so think cluster. And when you're thinking about cluster, think about this concept of always-on availability groups. And so that's what you need to remember and study when worried about any question with high availability for relational database structures. All right, now it's time to get a little bit into data warehousing. So when building and working with Azure Data Warehouse, you just need to understand a little bit about star schemas, and you need to understand about relational schemas, such as when would you use a star schema versus when would you use a relational schema. For the most part, data warehouses are usually made with star schemas, for the most part, when you have facts and dimension tables, right? And online transaction processing is done with facts and dimension tables. So if you understand that from your old DBA days, you pretty much have the couple of questions that they ask when that pretty locked down. Another important takeaway here is the massively parallel processing architecture. Now, this is an interesting one. With MPP, this is this concept, and again, this is a data warehouse type of thing. When you start to implement data warehousing in Azure, when you set up a SQL data warehouse, you have the ability of setting it up in such a way where you can create a processing node and what's called the following nodes, or the command node and the worker nodes. You can have up to 60 worker nodes inside of Azure Data Warehouse. So that means if you have this question that asks you to do massively parallelized queries, you need to query and you want to get up to 60 queries at a time running in sync in parallel, you need to understand that it's supported, but only up to 60. And the way it works is Azure SQL Data Warehouse, what it does is it starts to distribute your load using these 3 different type of patterns, okay? I don't remember too many questions on the replicated pattern, but I will talk about the hash and round robin because those are real easy to understand. The hash pattern is, as the data comes in, it creates a hash of it, and based off of the changes of that data, that hash is the partition. So that all the data that comes in that's similar gets hashed, and that hash value goes to that partition based off of that hash. So it's basically this hashing algorithm. The round robin is even easier. It's like eeny, meeny, miny, mo. It basically goes to this side, and then it goes to this side, and it goes back to this side, and then it goes back to that side. And so as the data comes in, it just filters between 2 distribution points in Data Warehouse. All right, and that's all you pretty much need to know there. But again, a good read-up on it would help out. Now, as we start to get into data warehousing, it would be remiss if I didn't talk about how to get data into the data warehouse in the first place. So that's what Polybase is all about. So Polybase is all about how do we extract data from, let's say, a CSV file or Azure Blob or network share, utilizing a query, utilizing SQL queries. And that's what Polybase is. So they do ask quite a few questions on this. So expect questions on things like what's the TSQL to connect to a CSV file or blob storage in order to get data into, let's say, a data warehouse or even a Databricks environment that we'll be talking about. Expect questions on how do you set up your Azure AD account in order to use Polybase, right? Expect questions on when is it best to use Polybase versus bulk copy versus some other third-party tool. And I'll give you some answers there. So when we talk about Polybase, we're talking about speed. The reason why you would use Polybase is because it's touted as one of the fastest ways you can do bulk data ingestion into your data warehouse or your Databricks environment. So if they ask you which one's going to give you the best performance and they give you SSIS, BCP, or third-party tools, it's most likely going to be this Polybase design, okay? Another thing that you probably want to think about would be the steps. So there are some predefined steps that you need to do in order to use Polybase. And those steps are, number 1, you're going to extract, let's say it's a text file, right? So you're going to extract the text file. Or basically, you're just going to extract the source some kind of way. Again, it might be from a blob storage, a network share, or something like that. So you extract it. So in Polybase, there's a way in which you tell it to extract. You first set the source, and you tell it to extract it from this source. The next thing you're going to do is you're then going to load from that source into either a blob storage or data lake or Hadoop, Databricks. The next thing you're going to do is you're going to import the data into a temp table into your data warehouse. And then that's where you run particularly most likely Data Factory to transform the data through a pipeline and eventually insert it into your production tables after it's been processed. So those are generically the steps. And when they ask you questions, they'll ask you things that deal with this step, all right? And it'll probably be in some design where they'll give you snippets of code that say, drag and drop the steps to do this type of thing. So there's a lab that shows you how to do this right on the Microsoft.com/learn website. It's in a Git repo, fairly easy to follow through. It sets up the environment for you and everything. So once you get the steps down, the couple of questions that deal with that are pretty straightforward. All right, so that's relational data structures. Almost there. Next piece of this would be managing the data security. So again, there's quite a few questions on how to secure your data in both a non-relational and relational data structure. So just be aware of them. Be aware of, we'll talk a little bit more about the transit at rest and stuff like that. But for right now, we have this ability to do what we refer to as data masking. So this is a nice new feature. So you remember how in SQL, anybody, if they had access to SQL Management Studio, SQL Enterprise Manager, you can open up a select query and see all the data inside of the table rows, including credit card numbers, including passwords. So we wound up having to do fancy stuff to encrypt the data in those tables. Well, the cool thing is that now we don't necessarily have to do that anymore. We can turn on data masking. And data masking allows you to choose an Azure Active Directory group or user accounts to say who can actually see those roles, and if they're not, who can actually see those values, and if they're not a part of that group or not in that particular identity, the data gets masked out, even in SQL Management Studio or Visual Studio. So what you need to know there about masking is you need to know about the masking functions. I put them up there. Those are the main ones. And you need to know a little bit about how to make a masking rule, and that's it. All right, so if you read up on masking functions and understand more about the fact that this is existing inside of Azure SQL, then you're well on your way to passing. All right, another part that you need to know about is this concept of encryption. So I'm pretty sure at this point everybody knows what encryption is. But now let's talk about how we have different forms. We have different types of encryption when we talk about data. We have when the data is encrypted at rest. So that means when it's sitting in the storage repository, inside of it, it's encrypted, or the repository itself is encrypted. So then we have encryption in transit. So that means whenever the data is being sent across the network to your client browser or your mobile device or wherever it's going, the protocol that's sending it across the wire should be encrypted. And then you have encryption at use, which is kind of this idea of masking, right? So whenever you're viewing the data, only certain people can see the data, or the data itself is completely encrypted. So know those different types. Know those types of encryption, encryption at rest, encryption in transit, and encryption in use. Understand masking, and then you should be pretty good. Let's talk about transparent data encryption for a second. Transparent data encryption is all about the fact that when you're using Azure SQL, Azure Storage for that matter as well, but specifically Azure SQL, Azure automatically encrypts your repository. The whole thing is encrypted. It's nothing you have to do. It's turned on by default. As a matter of fact, you can't even turn it off in version 2, in the latest versions. If you have some of the older versions, which they don't ask you questions on, you can actually turn it off. But the latest version of Azure SQL, it's by default turned on, you can't. And all that simply means is that by default, your database, if someone were to randomly get a hold of your repository some kind of way, when they get it, it's encrypted. The takeaway here about the already encrypted is how it's encrypted. You can use the keys that are automatically generated for you by Azure, or you can bring your own key. when you bring your own encryption key, you have to store that key in Azure Vault. Okay, how many people have heard of Azure Vault? Hopefully everybody. All right, good. For those that have not, Azure Vault is a certificate management, key management, identity management kind of like system that Azure provides to allow you to do things like securely store keys. So so the takeaway here is when you're using TDE, if you want to use your own key for encryption, you're going to have to use Azure Vault to store that key inside of it. All right. Next major bucket, managing and developing data processing. So this has two buckets inside of it. It is developing batch processing functions. We get to talk about some fun stuff, especially some of the new announcements that were made. And then we'll talk about developing streaming solutions. So to talk about the batch processing, I'm not going to put a bunch of bulleted words up here. We're going to first talk about the scenario, right? And think about how we go about asking questions about this. So envision, again, this application. You're a data engineer, and you need to support events that are coming in. Now, instead of that being Kafka, like it was in the first slide, in this case, we did it right. We used Event Hub. So the events are coming in through an Event Hub. Now, these events could be coming from an IoT hub, right? So IoT devices are sending in various different status and events, or maybe it's just a manual event that you created through some client application, mobile device or web application or desktop application. Whatever the case is, the events are coming in, and you're filtering off of these events and storing data into Cosmos DB. Once it's in Cosmos DB, what you probably want to do is you probably want to do some type of processing on that data, real-time processing on that data, or maybe you just want to do some type of mechanism where it's going through a machine learning environment, aka Databricks. That machine learning environment has data scientists and AI engineers looking at it, crunching numbers and doing all kind of interesting things. Okay? Now, to be a little bit more specific about Databricks, how many people here have heard of Databricks, by show of hands? How many people have used Databricks? Okay, even fewer. So Databricks is nothing more than Microsoft's version of Apache Spark. It is the complete environment for building machine learning models and running machine learning theorems to do predictive analytics, all right? And other types of machine learning models. So it's everything that deals with the compute power. It deals with creating clustered nodes of Apache Spark so that when you run your machine learning and you crunch your numbers, it's basically running in the cluster and in the process space of Apache Spark, all right? So Databricks is Microsoft's, not rendition, but Microsoft's implementation of that software running inside of Azure. So of course, you're going to get all the benefits of Azure by running it inside of Azure. Which means that it's not technically a Microsoft product, so there are some weird integration points that you have there with Databricks, and there's a lot of setup. And for most people, it's pretty much a pain to deal with because there's a lot involved there. But once it's all set up, especially if you go through Azure Databricks, it provides like a notebook environment for those data scientists, right? It allows you to use a Jupyter notebook to type in commands, and you can use things like Polybase to pull data down from a text file or from a blob storage and interact with that data as if it's right there native in your environment. And then you could take that data, run your various different algorithms, use TensorFlow, H2O, and all these different type of things, and then upload the data into Cosmos DB or Data Warehouse, right? Again, using Databricks and a mechanism that can ingest that data into your repositories. So this scenario is talking about all these different things that as a data engineer you need to be aware of. So another thing that we need to focus on is once it's in your Cosmos DB, then you're typically going to report off of it. So what type of reporting mechanism would you report off of it? Well, obviously you can use SQL reporting services, but that's not in Azure yet. You can use Power BI, right? And any type of reporting mechanism is available there. So when we're talking about developing batch process solutions, we're talking about all these different technologies that exist that we have to be made aware of when working with a design like this. So let's talk specifically about Azure Data Factory. By a show of hands, how many of you guys have heard of Azure Data Factory? How many have used it? Okay, just 3 or 4 of you. Azure Data Factory is an orchestrator. All it does is schedule and organize jobs that tells other systems when to do what they're supposed to do. So an example might be, you use Azure Data Factory through this graphical pipeline, and you tell it, go ahead and run Databricks on this data source. And Databricks, again, is an environment that you might have one or more algorithms or functions that runs through and crunches that data source and then spits it out somewhere. Azure Data Factory would then take the result of that, the output of that, and maybe uploads it into Cosmos DB. So if you go back to the first slide here, if the question is, how do we build a design like this, right? You know you're going to need something like Event Hubs, Azure Databricks, and the guy who kind of pipes it all together is Azure Data Factory. Another thing that you need to know about Azure Data Factory is that it's configured using a graphical pipeline as well as a JSON file. So you have 2 options of how to configure the orchestrator. I don't remember necessarily if there were any questions on the snippet of the JSON stuff, because I just don't remember seeing them, but they do ask you questions about when to use Azure Data Factory. And that takes us to the next topic, which is streaming. Oh, quick little shout out here for this one. Going back to the batch for a second. So if you're wondering about the new announcement with Synapse, Synapse is really all of this stuff that we talked about between these 2 slides. Synapse is that new cool feature, new cool functionality that was just announced this week that allows us to build in a Databricks environment, a machine learning environment, automatically set up for us to run through a data warehouse using Data Factory and Power BI. And it basically put it all together and packaged it as a packaged feature/product for us to make our lives easier. So that's the beauty behind Azure Synapse. All right. So the next topic is streaming. So that last topic was batch. Now we're talking about online, real-time streaming events. So whenever we need to deal with streaming, we use Stream Analytics. Stream Analytics is the way for us to take in multiple inputs. The inputs that are supported are Event Hub, Blob Storage, and I forget the last one. Event Hub, Blob Storage, and IoT Hub. Yep, both Event Hubs. And what that means is when they ask you questions that deal with streaming mechanisms, you just understand the inputs are always going to be something dealing with an Event Hub or Blob Storage for Stream Analytics. So as you configure the input, which is really easy, it's a graphical tool. There's also Azure CLI, but I don't remember any Azure CLI questions on how to configure stream analysis. Once you configure the inputs, then just know that you have to write queries now in order to do something with the data that's being invented and sent into your system. So the query might look something like this at the bottom of the slide here. It's just select statements. So when working with your stream analysis, what you need to focus on are your inputs, understanding the data format that you're getting in, and then creating a job, and that job itself has the query that you're going to build. Once we have this, then Stream Analytics can then process that data and send output to a Cosmos DB table, or an Event Hub, or Blob Storage. It can pretty much go anywhere in the Azure ecosystem. Right? So whenever you see a design, or it talks about a design that looks like that, just understand that we're just talking about streaming data, and we're talking about inputs that are coming from Event Hub, Blob Storage, or IoT Hub, and we're having some select query in Stream Analytics that allows us to select individual pieces out of that. Now, because we're talking about streaming data, this is real-time data that's coming in, we have to talk about windowing functions. Windowing functions are sliding functions that allow us to take a look at the data as it's being streamed in based off of timing periods. And so what you should know there and focus on are these 4 windowing functions. tumbling, hopping, sliding, and session. And the differences between these are tumbling is basically saying, give me the last 10 seconds of the data that just came in. So it just gives you 10-second increments of the data as it comes in. Hopping basically says, give me the last 3 records over 10 seconds. So in this case, or you may say, yeah, over 10 records. In this case, the hopping window says, if 3 records came in 10 seconds, it'll give you 3 records. But if 20 records came in, let's say, 10 seconds, then it'll hop and give you it in 3 record batches over that 10 seconds, all right? And then you have sliding windows, and then you have sessions. So when we talk about implementing event processing, key takeaway, you use Stream Analytics. Stream Analytics has inputs and outputs. It can pretty much output anywhere to any Azure resource. The inputs supported by Stream Analytics are Event Hub, IoT Hub, and Blob Storage. When you're working with Stream Analytics, you write queries inside of jobs. These queries have select statements, and you basically say select whatever the fields are, and it's going to go into the output. And you're typically going to use windowing functions in your queries to really filter out the data that you want to go to your output. Which takes us to the very last part of this, which is monitoring and optimizing data solutions. So this has 4 buckets, which is monitoring data storage, monitoring data processing, and optimizing Azure data solutions and troubleshooting. So the easiest way to really get a feel for the monitoring piece for this exam is to open up Azure Portal and click on every monitoring tab that exists for every data resource that you've instanced. When you go into the Azure Portal and you click on the monitoring tab, you just want to pay attention to the data that's in that monitoring tab. It's going to tell you things like how many errors have been generated. It's going to tell you things like how many requests have come in. It's going to tell you things like network speed, latency, right? It's going to tell you all of that information. So just understanding that it's all found in the Azure portal on a monitoring is step 1. The next thing you want to pay attention to is when you click on the individual data resource, such as when you go into Cosmos DB, right? It will even tell you which regions are mostly populated and mostly being accessed by putting little pin push markers on the grid there. It'll tell you how much data is coming in per minute, per second, right? All that information, again, can be found through the Azure portal, in this case, on the monitoring tab for the Cosmos instance that you have up there. And you should focus on that. When we talk about SQL database monitoring, it's the exact same monitoring tools that we've been talking about for years with SQL on-prem, but now a lot of these tools have been moved up into Azure. So just like there's table statistics, you can use the same thing in Azure SQL. Just like you can use Query Profiler, you can use the same thing here in Azure SQL. And all the monitoring things that you need to pay attention to for SQL, nothing's really changed there. Just think of it as it's now running up in the cloud as opposed to being on-prem. And guess what? The portal gives you a lot of that information already if you just go into Azure SQL and click on the monitoring tab. So just familiar yourself with the monitoring tab for each of the resources and just pay attention to the rates and the fields that are being populated. Another key takeaway here for monitoring is whenever you do have an actual error and you need to, we'll go back to the slide, and you need to troubleshoot that error, let's go here, there are some troubleshooting steps that you should be focused on. For example, if for some reason you can't connect to some resource, you can't connect to Azure SQL, you can't connect to a table instance in Azure Cosmos DB, what you're going to look for is, first thing you want to look at is the firewall. Make sure that your ports, the port numbers for those resources are available and turned on, they're enabled. So that's the first thing. The next thing you probably want to pay attention to is your security, right? Are you using Azure AD? If so, are you using the right username and password for Azure AD? All right, the right identity, basically. If you're working with SQL authentication, are you passing in the right username and password for SQL? Right, so you check your authentication. And then the next thing, if you just can't connect, then actually go out and check the Azure dashboard, the service dashboard, to make sure the service is up and running. Now, maybe you check that first. There's no particular order, but you just need to pay attention when troubleshooting connection issues. These are some of the things you should focus on. When troubleshooting performance, well, that's a much bigger list, because every repository is a little bit different, obviously. So troubleshooting performance, there are a lot of different things you should focus on. So let's think about non-relational structures for a second, Cosmos DB. So if you're working with, let's say, MongoDB, or you're working with the graph database or whatever, and you realize your queries are taking a long time, it could be something in the inherent design with the logical partitions and the physical partitions, right? Maybe you have the wrong partition key. Maybe it's not quite set up the way you envision. Because I quickly mentioned this concept of request units. What happens is by default, your request units, if they go past the amount of request units you have configured for your instance, Azure will throttle and rate limit your instance until a certain time period or until the number goes down again, and then it'll go back up to speed. Again, your request unit, or your RU, is what you're being charged off of, and you could choose how many RUs you have for a particular instance. So I think by default, you're given like 100 or something like that. So if you go past 100 in any given process or threshold, your rates slow down. So that would be one reason why your performance starts to slow down, okay? Another reason might be maybe your query is just off. Maybe you're doing a full scan. So if you scan all the partitions, it's going to be slow. And the reason why you might scan all the partitions, because again, your partition key, you chose a bad partition key, like that current date scenario that I gave earlier in the presentation, all right? But that's the non-relational side of things. When we talk about the relational side of things, right, again, a number of reasons why your query might be right. Maybe you don't have any indexes on your table, okay? Things of that nature. Your standard SQL performance mechanisms apply here when we talk about relational data structures, including data warehouses. Now, in the case of Azure Data Factory and Azure Databricks, if maybe the reason why Azure Databricks, that environment is slow, is because maybe you just didn't provide enough instances for your cluster, which you could tell it when you're setting up your Azure Databricks. Maybe the reason why Azure Data Factory is slow when it's ingesting data and sending data to various different resources is because maybe the service is timing out. And the only way, Azure Data Factory is much more harder to troubleshoot because it's something that runs inside of Azure that you don't have exact visibility into. You would have to use Azure monitoring to kind of get a feel as to what's going wrong. Maybe you check the service dashboard and see if Azure Data Factory is actually green and running or not. Right, so those are some of the things you need to think about when troubleshooting. Now, troubleshooting is not exactly on the exam, but it's just good to know, okay? So let's go back. So another thing that we have available in Azure is something called Azure Monitor. And what Azure Monitor allows you to do is allows you to see your network performance overall in general. And this is very good, especially if you look at the application gateway. This is a clear indicator if Azure Data Factory is timing out on you, is you looking up Azure Monitor and going into the network performance monitor and then going specifically into the application gateway. So these are kind of like the background services that are running and communicating. Key note there, Azure Databricks, again, that is Apache Spark. So you're not going to necessarily see a lot of information on Apache Spark running here, simply because that is another tool, another framework, and it's not exactly integrated into this environment, which is the beauty behind Synapse, because hopefully, and from what I hear, that one will be. All right, optimizing data solutions. So one of the topics that you see on the exam is how to go about optimizing your relational, non-relational structures. And to be honest, that's a very little part of the exam. And what I remember about that is really asking you questions like security threat modeling. So the best way to explain that and understand that is you go into Azure portal, you set up threat modeling by setting up what it is that you want to monitor, you turn on an alert, and then you run it, and when the alert kicks off, you have the ability of drilling down into that alert and seeing why your system got notified you in the first place. Okay, and that's kind of what I remember. And how does that fit into optimizing your SQL piece? Well, just knowing when your systems are being hit or being attacked, right? Being able to quickly thwart that attack is where this comes into play. All right. So this is an example of how the questions will be laid out. This is not a real question on the exam. I'm under NDA, can't actually tell you that, but I can tell you the format. A lot of the formats will be exactly like you see here. You're first presented with this scenario of what it is that you're doing. So in this case, it says, hey, you're a data engineer that works with Azure Data Pipeline, and your environment utilizes blob storage to store a large CSV file of car sales. So right there, you're presented with some facts. The facts are, you have a blob storage, has a CSV file. That's all you really need to know there. Then you're presented with what the problem is. The problem is that you have a data scientist apparently on your team, and they're complaining the slow import times for ingesting this car file. So I don't know if you're catching this, but early on, I gave you an example of when you use Polybase. This is a perfect example. You use Polybase because of speed, okay? There are other ways you can get this text file in there, but Polybase is your speed text file, Polybase. That's what you should be thinking. Next question is, your goal statement. You need to reduce the amount of time it takes to ingest your file. So right there, they're probably going to give you a couple of options on how to do this. They're probably going to tell you BCP, bulk copy. They're probably going to give you some whacked out mechanism, right? And it could be many questions dealing with this. But the idea here is that you're presented with a scenario, you're presented with the problem statement, and you're presented with what you need to do. And the question winds up being, what steps? So there could be many questions here. And this example is, what are the steps to do this? So it assumes that you already know that you're going to be using a particular technology, Polybase. It assumes that you already know that to set up Polybase, there are a certain set of steps, right? But the question could be many-fold here, right? It can ask you which option should you choose here to best handle this. And again, it might say build a custom application with a console app. It might say use PCP, right, BCP, and so on and so forth. So this might be the set of answers that you have based off of that question. Create a temp table to load the data, create a scoped credential, use the CLI to issue an Azure login request, create an external file, create an external blob, create an external data source, load the data into the SQL data warehouse, okay? Well, if you go back to the slides from before, we talked about this. We said basically there are certain steps that you need to do in order to set up Polybase. The first thing really is not up there, but it's create a master key. You'll see that when you go through the lab. But after you do that, you pretty much create a scoped credential. Nothing happens unless you've been authenticated to do that, right? So you create your scoped credential. The next thing you need to do is create an external data source, right? You need to point to where this data is. So it's a blob storage, so you need that data source to point to. So actually, you might create the external blob first, and then create the data source that points to the external blob, all right? So then once you do that, the next thing is that you need to create a temp table. You just don't load into the data warehouse. You actually load into a temp table first. So you would create the temp table to load it in, and then eventually you load the data into SQL Data Warehouse, all right? So again, the steps would be create a scope credential, this guy right here, then create an external blob that points to the blob file, then create a data source that points to that, then create a temp table to load the data from the data source, and then load the data into SQL Data Warehouse. And you may not remember exactly all of those steps and in that order, but if you step through the lab, it'll become pretty obvious. All right, so with all of that being said, how do we prepare? Well, We have many different resources that are available for you. If you go to microsoft.com/learn, it provides you with the role-based mechanism. So you go to Data and AI, then you choose the exam that you want, in this case, DP-200, and it gives you quite a few different modules there, hands-on labs and modules that you could step through in order to start learning all of this. Obviously, there are events like this that give you exam prep sessions. There's also instructor-led classrooms that are available and all of that. And if you go to the Certification Learning Center in the hub, there's also some hands-on labs there. So we have some live hands-on labs that you can partake. And don't forget about your free exam that's available. If you take a picture of this link here, this link is available for you to take this exam for free for up to 60 days. Starting on the last date of Ignite. So starting Friday, you have 60 days from that date to use this voucher to take this exam or any of the role-based exams that you'd like to take. So with that, thank you guys for attending. And don't forget, tomorrow we have the second half of this, which is understanding and doing an exam prep for DP-201, which is the second part of the exam to go for the data engineer certification. That's going to be held Thursday. And please do not forget to fill out your evaluation by going to this link here and give me some kind words of endearment. Thank you, guys. My name is Dwight Goins. Hopefully that was good. Hopefully that was good.